Question number 11, 12 and 13 is based upon this particular given paragraph here. It is a biconvex lens of R1 is equal to 10 cm, R2 is equal to 20 cm and mu is equal to 1.5 is placed between two media of refractive indexes. Mu1 is equal to 1.2 on this side and mu2 is equal to 1.8 respectively on this side. A small object is placed at distance 30 cm from the lens either in medium 1 or in medium 2. Now the question number 11 is, if the object is placed in medium 1, then we need to find which one of the given options are correct. Let's start with the calculation here. This is the medium 1, this is R1. So incident ray is from this direction. So I would say mu2, this time it is 1.5 by V1 minus mu1, it was 1.2, u being minus 30, so it is plus 30, would be equal to 1.5 minus 1.2, it is 0.3 and R1 is 10 centimeter. Now the ray will be refracted on this side, so here it is 1.8 final image distance V minus 1.5 V1 would be equal to mu2 minus mu1 would be equal to 1.8 minus 1.5, 0.3 and R here is minus 20. Just have this calculation here. We shall be getting 1.8 V plus 1.2 divided by 30 would be equal to 0.3 by 10 minus 0.3 by 20. It will be 0.3 divided by 20. So it is 1.8 divided by V is equal to 3 by 200 minus 1.2 divided by 30. It will be 8 divided by 200. That means it is minus 5 divided by 200. So the value of V, it is coming out to be 1.8 into 200 divided by 5 with negative sign. So it is 40 here. 40 into 1.8, it is 72 with negative sign. So we are getting the answer as the image distance is 72 centimeter from lens and the image is virtual. So option B and D are the correct answer for question number 11. Now let's proceed to question number 12. Question number 12 is also very similar. If the object is placed in medium 2, then we need to find the similar type of calculation here. This time here is the object. So I would say mu2 by V, that means 1.5 divided by V1 minus 1.8, it is 30 here. Here 1.5 minus 1.8 minus 0.3 and 20 here. For the refraction on this surface, I would say 1.2 V minus 1.5 V1 would be equal to 1.2 minus 1.5 minus 0.3 divided by minus 10. So it is 0.3 divided by 10. Have this calculation. I would say 1.2 V plus 1.8 by 30. It is 0.3 divided by 20 or 3 divided by 200. On calculation, we'll be getting 1.2 divided by V would be equal to 3 by 200 and here it is 12 by 200. That means it is minus 9 by 200. So V, it is coming out to be 12 by 10 into 200 divided by 9 with negative sign. So altogether it is minus 80 divided by 3. So this value of minus 80 by 3 is coming out to be 26.66, or I would say option C. And clearly yet again I would say the image is virtual. So we are getting option B and C as the correct answer for question number 12. Now let's proceed to question number 13. In question number 13, it's been said that if mu1 is equal to 1 and mu2 is equal to 1, then how the image would be formed and what is its distance, and actually magnification has also been asked there in the question. So we shall proceed in the similar fashion as we did earlier. So clearly this time if I would write the equivalent focal length of the system, then perhaps that will be easier for me to calculate the answer. So 1 by f would be equal to mu minus 1. Mu was 1.5, that means 1 by 2. 1 by r1 minus 1 by r2. Taking the sign convention, I would say 1 by 10 plus 1 by 20, or it is 3 by 20 into 1 by 2. So this is the value of 1 by f. So if now the object is placed at a distance of 30, that means 1 by v minus 1 by u. U is how much? Minus 30. So it is 30, would come out to be 1 by f, that is 3 by 40. Or 1 by v is equal to 3 by 40 minus 1 by 30. And it is 90 minus 40, it is 50. Divide by 40 into 30. This 0 will cancel out, 5, 8. So effectively v is how much? 24 centimeter. So image distance is at 24 centimeter. Object distance was 30. Definitely the magnitude of magnification would be 24 by 30, or it is 4 by 5. So D is the correct answer. Image is real and the image distance is 24 centimeter. So for question number 13 we are getting option A, C and D as the correct answer. Now let's proceed to next question. Here also another paragraph has been given on which the question 14 and 15 is based upon. So the paragraph is 12 identical wires, each of resistance R, are joined to form a cube as shown in figure. The vertices are marked A, B, C, D, E, F, G, H here. So question number 14 is, if an ideal battery of EMF V0 is connected across vertices A and B, then we need to find what is the current through different branches and potential difference across E and F and G and H. Definitely looking into the picture, if it's been connected across these 2 points, so AB is definitely a one particular independent path here. Another path being AEFB, AEFB and ADCB. ADCB. These 2 paths are symmetrical with respect to each other. That means E and D and F and C would be at the same potential. So potential difference across EF. EF, here it is certainly not 0. Potential difference across GH, here GH, certainly this is also not 0. So we are now confirmed with finding out the value of the current in the branch BC here. For that, let's try to just redraw the simplified circuit diagram here. This point is the starting point A. From A, one path is ADCB, A to D here, other being AEFB. This is D, this is E. On the other side, it was B here, B to C and B to F. This is F and this is C. Now from E, one connection is directly to F itself, and from D, other being directly to C itself. So from D, another part is connected to H, and from E to H also. This is D, H and this is H. Then H to G, this is G, and from here G to C and G to F. This is G and these 2 points are F and C. And one more connection is there, that is from A to B. Okay, this is the simplified circuit diagram for the above arrangement. Current through the branch BC, just try to evaluate the equivalent resistance of this much of the portion only. Branch BC is actually this branch. So whatever be the current, half of the current will be flowing across this BC branch here. So this part being how much? R by 2. This is R by 2, R by 2, R, and here it is R, so it is 2R. So this is R and R, so it will be R by 2. So effective resistance of this much of the portion is coming out to be this one, and it is actually how much? R1, I'm writing it down as 7R by 5. That means the current across this segment, it would be how much? It would be V0 divided by 7R and 5 here. So the current across BC will be half of that. So current across BC, it will be 5 V0 divided by 14R. It is not matching with the option here given in A. Now let's find the current through the battery is. Already the current through this much of the segment is coming out to be 5 V0 by 7R, and the current through this branch AB, it will be V0 divided by R. So the total current, it will be 12 V0 divided by 7R. So option C is matching with the answer. So for question number 14, option C is the only correct answer. Now let's proceed to question number 15. In question number 15, which is also based on the same above given paragraph, if an ideal battery of EMF V0 is connected across vertices A and C, across these 2 points, then this time yet again I would say the path ABC and path ADC are symmetrical path. So ADC and ABC are the symmetrical path. That means B and D would be at the same potential. Another different path is AEHGC and AEFGC. Point H and F are exactly midpoints of the path, so that means the potential here also would be same, and that will be same as the potential of B and D. So if we try to redraw the diagram here, we still be left with this situation. That means the current in the branch DH and BF would be 0. So let's see if that's actually being given here. Potential difference across B and F is 0, that is correct answer. Potential difference across D and H is 0, that is also the correct answer. Current through the battery and current through the branch BC. This is the branch BC, and we need to find the total current through the battery now. The current through the branch BC is V0 divided by, this is R and this is R. Clearly current in BC is V0 divided by 2R. Current in this branch also is, current in AD is V0 divided by 2R, and current here on this side, this is R, this is R, also these two are R itself, so it is 2R parallel to 2R R, and this is R, this is R, it is actually 3R. So current in AE V0 divided by 3R. So total current through the battery, it will be sum of all these three. That means V0 divided by R. 1 by 2, 1 by 2, it is 1 plus 1 by 3, or current is coming out to be 4 V0 divided by 3R. So option A is also the correct answer. So finally we are getting option A, B and C as the correct answer for question number 15. Now let's proceed to next question.